This video will be part 5 of the series on automating the Accu-Slice system. In this video, we're going to be automating the indexing system. I'll be automating this first prototype. I've already designed my electronics module. This is a module which contains my Arduino board, a power supply, a driver for the stepper motor, and all the controls to operate the system. And I also wrote the software. Software is all done to operate this. I originally wanted to just take my existing indexing system, take off the knob, add a stepper motor, and that would run right from the system there. But the problem with the stepper motor is too big and it interferes with this bar here. So I have to raise this indexing system. So I made an addition here. I made this on my little mini mill. It consists of my regular indexing system, which has been modified slightly, and then mounted to these various pieces of metal which have been machined to allow the stepper motor to attach right to my indexer. And this will be screwed, this plate to the first plate here, and the second piece of metal here to the second plate. And then the stepper motor should drive it in and out. So this is my first prototype. It's my first choice because this screw in here, the pitch on that screw is 20 threads per inch. So with my stepper motor operating at 400 steps per revolution, that would give me, 8,000 steps per inch. So I should get pretty accurate indexing of the system. My concern is this screw is really not designed for this type of operation, so it may have a little too much backlash. So I'll have to check and see how accurate it is going forward. If this doesn't work to my satisfaction, I'm working on 2 other designs using stepper motor assemblies. And again, this will just mount on the system. I somehow figure out how to mount this on here, and it'll automatically index the system. The disadvantage of this is this screw system is around 5 threads per inch. So it actually may not be as accurate as this system. So I'll have to wait and see how this works, and I'll determine how to go further. I have one other idea, and that's using another driver system. The advantage of this system, it has 2 guide bars. So this system would be the ideal system to make sure these pieces of metal on my Accu-Slice system stay perfectly parallel to one another. It would act much like my bars on the end. I actually have 4 bars guiding this system into the bandsaw blade. So this might be very accurate. So it's another possibility, but I'll wait and see how this first prototype works out. I am making this as a standalone system. In other words, I'll have my separate controller and my separate indexing wheel, because this may be very useful to people who don't want to automate the entire system, but they want to automate the indexing system. I have had questions from customers about, first of all, metric. They want to do all their indexing in metric. It would be very easy to change on this. Just change my software to have it operate in metric. I've had other customers who want to deal in fractions. Again, we could do the same thing. We could deal with fractions because the software can be modified to do that. So the first step now going forward to make this first prototype system work is take off my indexing system. Then I have to drill some holes and tap them. They should be drilled and tapped in order to mount this to the Accu-Slice system. This is the control box for the new Accu-Slice Auto Indexer, which is designed to operate the indexing system on the Accu-Slice system. I put all the components in a small little box here with a panel here with the various switches. On the back I have my inputs for my power input. This is the input for my stepper motor. Then I also have the connection here to go to my computer. On the system itself I have a variety of buttons. The system is designed first of all to input manually the thickness of board you want to cut and also the blade curve. I have a digital display here which comes up, and then you select how thick of a board you want to cut. You enter that, you dial that in, the thickness you want. Press the enter button to enter it. Then you select your curve for your blade. Again, same thing, adjust it between, say 45 thousandths or 55 thousandths. Set that, and those numbers are programmed in so that when you run the system, when I press run, it'll advance that bandsaw blade. First of all, the curve for the blade, and then also the thickness of the board you want to cut, and then you can cut. When you're ready for the next cut, you just repeat the process. Run and stop because it's all set for the next system. When you're all done running, you want to run the system back, so these jog buttons will quickly move that indexer back and forth. One of the nice advantages of this with the software all written, I can change the mode of operation. I normally deal in thousandths of an inch, But a lot of customers deal in fractions, or some customers deal with metric measurements, and they want to change that. Well, that can be changed very easily with the software. I could operate this in metric, so you could deal in millimeters to dial in your system. So that can easily be done. This is a reset button. After you've run a board, maybe you want to do a different thickness of board, you press the reset, and then you reset your system for the board width and also the curve of the blade. So it can all be manually changed. And these are just two power lights. Number show you when it's running, and number 2 over here, the red one, is stopped. In order to attach this system, I need to remove the old indexing system. So this is attached with screws underneath. I'll have to remove those screws, pull this off, and this will get attached in its place. This is designed with a machine piece that rests on the bar like this. I'll have to drill some holes in this bar to screw it in. Likewise, I'll drill holes in this bar to screw it in. These holes will be drilled and tapped. So I'll put screws in here and actually tap it and screw it to these bars. And then once that's set up, this motor will drive it in and out. This was designed, again, I designed it and then I machined all the parts on my mini mill of various metal parts. It's a metal plate here that attaches to there, and another plate here which attaches to the other part of the indexing system. And again, they're all indexed and screwed in place. And then a stepper motor attaches to the plate here because that's thick enough to hold it. And of course I have a connector here to connect my stepper motor to my indexing wheel. I actually did turn down the knob on the indexing wheel slightly to make it fit the connector. So that's all set to go. So the next step is to take this off and then drill some holes and tap them for the new indexing system. I'm going to go ahead and try and remove this without taking it off the system. See how it works. I may have to take the whole system apart in order to change this out. So the first thing is to remove the old indexing system. It turns out I don't need to remove those 2 pins because I have holes drilled through here to align with the block on here. So the same holes I can use to put that in there. So that's there. So that makes that easy. So now you just have to drill and tap the holes for these. So let me try and get these tapped straight. Put a little cutting fluid on my tap. And this is a 1032 tap. One done, let me go and do the other 2 holes. And now I can drill and tap the holes for the second piece. This is how I do this when I align a system after I make them. I put usually a 1/2 inch or 5" each bar through here and then clamp these tight, and that just makes sure everything stays nice and parallel as you're attaching everything. So I just turn this, now these 2 are tight and have bars, so these 2 plates now are perfectly parallel to one another. Now I can go ahead and drill the 2 holes. Okay, so let's go and reattach the system. Okay, so now we're ready to start testing. And let me show you how this control works. We have a digital display here, and it's asking for the board thickness. So when I want to dial in a board, say I want a board 100 thousandths inch thick, I just turn this till I get 100 thousandths. There's 100 thousandths. Once that's selected, I press enter. Then it's asking for my blade curve. My typical blade curve is 45 thousandths, so I dialed in 45 thousandths. Press enter. So now it's telling me I'm cutting a board 100 thousandths inch thick, and my blade curve is 45 thousandths. Now I can run this manually, jogging back and forth, or when I say run, it's going to push it in the sum of those two distances, and it's going to push this system in 145 thousandths of an inch to make my first cut. So let's go ahead and give this a try. Let's try it manually first. Okay, so once I had my board set, if I wanted, had it all set, I wanted to cut my first board, I would just say run, and that automatically takes in 145 thousandths. Now the system designed, it ramps up slowly, goes my distance, and it slows down real slow at the end. It's called an acceleration. And what that does, that should give you a very accurate adjustment. So when I press run, see it moves slowly, accelerates a little bit, and then slows down. Now you have to turn it very slowly, because the slower you turn, of course, the more accurate it's going to be. So again, press it, it advances, it's moving it in. And just keep repeating the process. Now one thing nice about this, after you say you run a bunch of boards, and you want to move this back to the starting position. In the past you had to go, dial to get it back. Now I just press jog, and I can bring it back to the starting position. And I actually I'll set that up eventually to run a little bit faster than that. But it's better than sitting there turning it by hand. And when you hear that cranking, that means it's reached the end point. I just shut down my bandsaw and retuned it because I was getting a lot of vibration in the table. And when I took it down, I noticed that the blade on both the top and bottom was not touching my back ceramic, or if you have bearings, same thing. If that blade doesn't touch the back ceramic or the bearing, the blade moves, and as you start to move the board into the blade, it moves, and when it moves, it shifts on you. So it's important that blade be attached or be in contact with your back bearing or ceramic in this case. I also adjusted my side bearing because they were pretty loose, especially on the bottom, they were really loose. So it's nice and tight now, and it definitely runs a lot smoother. So now I'm ready to start doing some cutting. I have my board thickness set to 50 thousandths, my curve to 45. So we'll see how it works and how consistent it is. So release my mag jigs, and let's run it in. Make sure they're closed. It moves slowly, accelerates a little bit, and then slows down. And then tighten my mag jigs, and we're ready to run. I'm running right around 10 inches per minute. And this is a new 1/2 inch wide blade, 10 teeth per inch, a little finer blade. It's liable to gum up a little bit, but this is poplar, it should be okay with that. Once again, I am running this video at 5 times the actual speed just to reduce viewing time. That board came off perfectly straight and parallel. Nice smooth finish because it's a pretty fine blade, but it's measuring like 25 thousandths. It should be measuring 50. So either something's slipping or my calibration is off in my system. So I need to run some more boards to confirm what's going on. Release my mag jigs, run this in, tighten my mag jigs, and we'll run another board. And I'll keep doing that, doing a couple boards to see how consistent we are. And I cut 10 boards off that at the same setting of, it should be around 50,000 inch thick, but I know I got some variation, so let me see what the variation is. What I did here is I measured all 10 boards on all 4 sides to see that they were consistent and parallel, which they indeed were, and then I recorded the results for all 10 boards to see what the variation in thickness was between all 10 boards. So I have a variation between 40 and 49 thousandths. That's a lot more than I'd like to see. Not quite sure what the issue might be. Maybe the motor is too small, it might be slipping every now and then. Maybe my connector here is slipping. Maybe my setting. My setting is set at 400 steps per revolution. I can do micro stepping and get it up to like 1600 steps per revolution, which would give it like 4 times the resolution. So that's something I might try also. This concludes this video on my first version of the auto-indexing system for the Accu-Slice system. For this system, I used the existing indexing system for the Accu-Slice system. I just adapted with some clamps here to adapt a stepper motor. It worked pretty well, but I wasn't quite happy with the accuracy of the system. I got a variation of plus or minus say 0.004 of an inch, and I would like to see better than that. So that may be due to a couple of reasons. Maybe the stepper motor is not big enough and it might be slipping a couple steps. So I'll be going and ordering a larger stepper motor. It'll take me about a week to get a new larger stepper motor. I'll also be looking at increasing the number of steps per revolution on my stepper driver. Right now I'm running at 400 steps per inch. I can increase that up to 16,000 or 32,000. Each time I step it up, it'll increase the accuracy of the system. So I'll be looking at that also. But the problem may be the actual screw in the indexing system. Maybe it's not good enough or strong enough or accurate enough to do what I want to do. So I'll be looking at all those going forward, and I'll keep you informed of those steps as I complete the additional testing. If I can't get it to meet my expectations, then I will be going and trying one of the other designs. So in the meantime, I'll be working on this system, continuing to adapt it, do some more testing, and then possibly working on a new design. So once again, if you have any questions or comments, please give us a call or drop us an email. And once again, thank you for watching this video.